Let's look at question 12 of our general physics examination revision questions. Question 12 here says a woman stands on a bathroom scale in an elevator that is not moving. The scale reads 500 Newton, full stop. The elevator then moves downward with a constant velocity of 5 meter per second. What does the scale read while the elevator descends with constant velocity? A 100 Newton, B 250 Newton, C 500 Newton, D 600 Newton, E 750 Newton. So how do we solve this question? Let's take down the solution to this question. So solution here. All right. Now, the first thing we want to do here is to draw a free body diagram of the woman. So we say draw a free body diagram. Of course, the free body diagram will be of the woman. Let's see how we can do this. So just do this, and then this, and then this. So let's use this to represent the woman. Now, going back to the question, they said she was standing on a bathroom scale in an elevator that is not moving. Now, when she stands on a bathroom scale in an elevator that is static, that's not moving, what are the forces acting on her? Of course, obviously, her weight will be acting downwards. That's the first in there. You have the weight acting downwards. Also, you also have that her normal reaction is acting opposite her weight. So normal reaction will act upwards, opposite her weight. So we have this. We'll call this Fn, or we call this, okay, Fn, that's normal reaction or normal force. Acting downward will be weight W, which is given by the product of mass and gravity. So you have this. All right, so what's the next thing there? They said the scale reads 500 Newton. Now, if the scale is reading 500 Newton, that means at rest, or when the elevator is not moving, for scene one, all right, elevator is static. When the elevator is static, the scale reads 500 Newton. That means the weight of the woman is equal to 500 Newton, because the function of the scale there, right, is to read the weight on it. So if the scale reads 500 Newton, that means the woman's weight is about 500 Newton. Okay. Next thing here, they said the elevator then moves downward with a constant velocity. Now, when somebody moves with a constant velocity, what happens is that there will be no acceleration, right? And if there's no acceleration, the woman's weight will remain constant, right? That means the weight would not change. Now, what does the scale read with? What does the scale read while the elevator descends with constant velocity? What scale will be read? Next up, let's look at scene 2. When elevator moves. Now, when the elevator moves, they said the velocity v is about 5 meters per second, and this is constant. Okay. Now you're asked to find what does the scale read while the elevator descends with constant velocity. All right. You want to know that when a person is moving, right, the when a person is descending from an elevator, the forces acting are just in the vertical components, right, or in the vertical direction. That's the normal force and the weight. And for the person to be in equilibrium, for equilibrium, the summation of the force act on the person, of course, in this case, the vertical component is equal to 0. Now, vertical component, because the person is moving, the person is descending, that's moving in the vertical direction like this, all right, should be equal to 0. Now, if this is not equal to 0, the person would either go up or fall down. But if the person is standing straight while it descends, it means that there's no change in the vertical component, that sum of the vertical forces is equal to 0. Now, looking at vertical forces, we have this. Since the person is descending, that's coming downward here, you have this, right? You can see that the weight is in the same direction as the descending motion. So we have that weight is, that means the sum of forces, sigma F, is equal to weight, positive, because it's coming downward, same thing as the descending elevator. Then normal reaction is going upwards, opposite direction, so it becomes negative. So you have this minus Fn, normal reaction. All right, so with this, let's proceed. But we said that this is equal to 0, but we already said that sum of vertical forces is equal to 0. So what that simply means is that this is equal to 0. So W minus the normal force is equal to 0. All I have to do is move normal force over here. So I'll have that W is equal to Fn, normal force. But the value of W is already equal to, let's see that value again. What's that value again? 500 Newton. That's 500 Newton. In essence, 500 Newton is equal to the normal force. So while the woman is descending, the elevator will be reading this same force there, the normal force. So that will be the same weight the woman had. So while she is descending from the elevator, her weight would neither increase nor decrease. It remains the same. So the answer there is 500 Newton, right? And this makes sense because and being in an elevator does not automatically reduce your weight. No, all right, your weight will still remain the same thing. So it means 500 Newton. Yeah, so that's how you solve this question, right? All right, guys. So question 13, as usual for you, it says a block is at rest on a rough inclined plane and is connected to an object with the same mass as shown. This one here. The rope may be considered massless and the pulley may be considered frictionless. What is the magnitude of the static frictional force acting on the block? So if you can solve this question, solve it, leave your answer in the comment section. We already revised this, right, in our previous class. So you can check the playlist on mechanics, right? Go down the playlist, you see a video on this, right? So you can try to solve this question, leave your answer in the comment section, and I will tell you if you're correct or not, okay? All right, guys. So as usual, if you enjoyed this video, don't forget to hit the like button, right? Give this video a thumbs up. Don't forget to also leave a comment. For the comments, I give you a task, this question here. Solve this question, leave your answer in the comment section, and I will tell you if you're correct or not. Don't forget to also subscribe. If it's your first time here, do want to subscribe to this channel and hit the bell icon so that you get notified whenever we upload new content. Then finally, do want to share this video to your friends and your colleagues so that they can also learn. Thank you and see you in our next class.